Right, let us start that composite function concept. Okay, if f of x and g of x are two functions with g of x already given and f circle g also given, we need to find f of x. Yes, students, g of x is given, f circle g is given, find f of x. So, just it is option verification actually here. Look at here. F circle g of x can be written as f circle g of x can be written as f of g of x. Am I right? Okay, by composite function. We can multiply. So f of g of x already given x minus 1 by x. X minus 1 by x. So if we choose which one of the following options, if we substitute these value, we are going to get x cube minus 1 by x cube. Okay, when we give x minus 1 by x, substitute in place of x in our given options, which one of the option will be get x cube minus 1 by x cube? All of you check it once. Yes. First option, when we see here, first option, x cube plus 3x is there. Substitute all of you in place of x, x minus 1 by x. And tell me here. 3 into, sorry, x cube is there. X cube is x minus 1 by x whole cube plus 3 into x minus 1 by x. All of you simplify this. A minus b whole cube, a cube minus b cube plus 3a square b plus 3ab square, like that. Otherwise, a minus b whole cube can be written as a cube minus b cube minus 3ab into a minus b. You can write any one of the way. Just check it. Is the first option satisfy that given condition? Then it is right. First, otherwise, this right x cube minus 1 by x cube, can you able to write like this? X cube, a cube minus b cube minus, yes, minus 3ab into a plus b. 3ab into x into 1 by x. If you want, I'll write very clearly. This is an easy question. So 36. Okay, fine. See here. First option is f of x is equal to the given x cube plus 3x. Here f of we got like g of x value is x minus 1 by x. Now you have to replace x by x minus 1 by x. When you substitute here, x minus 1 by x the whole cube plus 3 into x minus 1 by x. I replace in place of x, x minus 1 by x. Now, since we know that the formula a minus b whole cube can be written as a cube minus b cube minus 3ab into a minus b. Is it true? Is it correct, students? Yes. This is a formula. We can, I want to use a cube, x cube minus 1 by x whole cube minus 3a. A is x, b is 1 by x, x minus 1 by x. Plus 3 into x minus 1 by x. Now look at here, here x get cancelled. Here x cube minus 1 by x cube. So what do you observe, students, here? X get cancelled, remaining minus 3 into x minus 1 by x plus 3 get cancelled. See, we got required. This is output f of g of x values. We find this value we got as x cube minus 1 by x. Okay, so first option is right. In the same way, even you can take the remaining option. Remaining options won't be satisfied the condition. We won't get x cube minus 1 by x cube when we find x minus 1 by x. Simple student, f circle g of x I substituted. I found f of x minus 1 by x with the help of the options. That's it. First option is satisfied. Next, 37 question. F of x value is ax plus b. 37. F of x value is ax plus b. And what is g of x they given? Cx plus d. Yeah, all of you observe very carefully. Two functions are given, and a is equal to 1, b is equal to 2. Already given. A is equal. Assume that a is equal to 1, b is equal to 2. And here f circle g is equal to g circle f. What can you say about C and D? C and D. Okay, I want to substitute A is equal to 1 here, B is equal to 2 here. F of x becomes x plus 2. So f of x becomes x plus 2. G of x is same, cx plus d. Am I right? Fine. So after this, I want to find f circle g of x. First, f of g of x. F of g of x, f of g of x value is clearly cx plus d. So again, what is f of x? X plus 2. Here x plus 2, in place of x here we are having cx plus d. Substitute in place of x cx plus d, cx plus d plus 2. So finally, f circle g of x value we got as cx plus 2 plus d. Okay, fine. In the same way, g circle f of x, g of f of x. So g of f of x value is x plus 2. Now g of x value is cx plus d. In place of x, substitute x plus 2, then plus d. So this is equal to what? Cx plus 2c plus d we got. 2c plus d we got. So what do you observe here? This is f circle g. Okay, that below one is g circle f of x. Okay. From these two equation, which one of the following options are satisfied? C and D both will be arbitrary. What does that mean by both will be arbitrary? The meaning of this is you can take any C and D. Any C and D, like any value you can give, any real number you can give for C and D. Both the equations are equal. Is that true? Yes, students. If I take, for example, C is equal to 3, some D is anything, see here, only D will be there. D always equal to D. If I give C is equal to 3, is here both F circle G circle F are equal? See, okay, CX, these two are also equal. But only the thing is here 2 will be there, here 2C will be there. This is the only difference for both the equation. CX, okay, no problem. D, no problem. You can give any D value here, okay. But whereas here 2, but here 2C. For what value of C? Here 2C is equal to 2. Yes. For what value of C? Here both the equation becomes equal. For every D value, it will be D equal to D, no problem. When I give D substitute here 10, here also 10. D substitute minus 100, here also minus 100. Okay, D equal to D, Cx is equal to Cx, but 2 will be there. 2 is a constant. This 2C becomes 2. When 2C becomes 2? Yes, students? When C is equal to? When 2C is equal to? 1. Then why are you responding so late? I'm asking to everyone. It is not a difficult, whether you are concentrating or not. I'm getting that down. C is equal to 1. D is any value. For any value of D, D equal to D. So, in C is equal to 1 only, 2 is equal to 2. Both the equations becomes true. Second option is correct. Okay, D is orbital. So this is obviously correct. This is wrong. C is not orbital. C must be equal to 1. So fourth option also correct. But the thing is, D is any value, not only 1. You can give, take 2, 3, 4, to plus infinity, minus infinity, up to minus infinity for any value. When C is equal to 1, it will be satisfied. Okay, right, next. F of x is equal to sine square x, and the composite functions g of f of x is equal to modulus x is given. Then the function g is any one modulus x. So what is the mean by this? This is again easy. Clearly they given here g of f of x clearly equal to modulus sin x. G of what is f of x value? Sine square x is equal to modulus sin x. All of you see here, sine square x also can be written as modulus sin x the whole square also. Square, even you can take modulus also becomes same. Square always positive, modulus sin x whole square also always positive. Is equal to we require to. For what value of the given options, when I take g of x is equal to square root of x minus 1, are you going to get output? In place of x here, in place of x, substitute modulus sin x the whole square. Okay, for which one of the all option, if you choose as a g of x, will get the output is modulus sin x. If I choose the first one, x minus 1, we are going to get square root of modulus sin x the whole square minus 1. Is it equal to the output modulus sin x? No. For second option, square root of modulus sin x the whole square, input you can give. Square root get cancelled. The output we are getting. Very simple. If I take g of x as root x, they are asking g of x. G of x, if I take root x, second option. So what is the, in place of x here, what is the value we are having? Modulus sin x whole square. Substitute in place of x. Modulus sin x whole square. Square root cancel. Finally, we get modulus sin x. Second option. Okay. Third option also we cannot consider. Yes, right side is plus will be there. Plus root square root of x. Anything doubt? Just substitute f of x value. You can f of x value you can write as modulus sin x whole square. Then option verification. That's all. Then question number 39. All of you. Question number 39. They define the function from R to R, G also R to R. Domain is real number. Codomain is real number. Given by G of x is modulus x. Sorry, f of x is modulus x. G of x is greatest integer function. And also they given a condition. When this condition is applicable, it is for only Z union negative real number. Minus infinity to 0 means R minus. Integer union R minus. Okay, other than 0 here. Okay, anyhow, minus infinity to 0 are only integer or real number. Or are real number. So let us see this question here. So I'm going to take the function f is defined from where to where? R to R. Question number 39. F from R to R, they given as f of x is equal to modulus x. G also from R to R, they given g of x as greatest integer of x. So and also then they have taken like the condition g of f of x lesser than or equal to g of f of x is lesser than or equal to f of g of x. All of you find first this values. Okay, now I want to substitute here. What is f of x, student? F of x. Left side. F of x value is modulus x. Is lesser than or equal to f of g of x is what, student? G of x is the greatest integer function. Okay. See, f of it's for g of f of x value I substituted here. G of x I substituted here. Finally, what is g of x? G of x is the greatest integer of x. So here left side we are getting greatest integer of modulus x. Because in place of x here we have in modulus x. When I substitute modulus x here output we are going to get greatest integer of modulus x. So greatest integer of modulus x lesser than or equal to f of x is modulus x. F of greatest integer is modulus greatest integer of x. So finally, if I take the given condition, already this condition is they only given g of f of x lesser than or equal to f of g of x. When I find that, we got like that greatest integer of modulus x absolute function, the absolute of greatest integer lesser than. Okay, now is it satisfies for what value of x both will be equal or lesser than? Yes. Let us take equation. Equation 1 satisfies only for integer. For example, see here. Third option only integer will be there. Is it not satisfied for any real number? Take some x values positive and negative. For example, if I give the x value is your wish. Like I want to take x value as some values like x is equal to some 1.9 have given. Let us see LHS and RHS. 1.9. So what is LHS? Greatest integer of modulus 1.9. Whether it is satisfying or not. Greatest integer of 1.9. I'm checking whether the equation 1 satisfying or not. Okay, what is modulus 1.9? 1.9. Lesser than or equal to? See, modulus 1.9 value is clearly 1. Okay, here again greatest integer of 1.1 is 1. 1 lesser than or equal to 1. Equation 1 is satisfies. For example, I want to take any negative values. Let's see here. Negative values. When I take x is equal to, you can take any negative values like okay, say minus 1.9 you can take. Okay, you can take 100 point minus 100.9, 100.8, your wish, any negative value. So LHS, when I see the LHS, here the greatest integer of modulus minus 1.9 lesser than or equal to modulus greatest integer of minus 1.9. So here both will be, here we got 1 is equal to 1. So here the condition is that equal is there, lesser than is there. Okay, we got equal. When I take positive value, when I take negative value, so can anyone tell that what is the modulus of minus 1.9? Shall I take plus 1.9? Students, plus 1.9 lesser than or equal to modulus. Yeah, greatest integer of minus 1.9 is clearly equal to anyone?
Minus 2.
Minus 2, modulus minus 2. Okay, here greatest integer of 1.9 is clearly 1, lesser than or equal to 2. Now what do you observe here? When I take a, I'm choosing a real numbers. I'm choosing real number. 1.9 is real number. Minus 1.9 also real number. Like you can take any real number, either positive or negative. So this equation 1 is satisfying. See here we got here 1 not lesser than or equal to, lesser than. So it is satisfy equal, here 1 is equal to 1, here 1 lesser than and 1. You can choose any real number. Equation 1 is true for every real number. For every real number it is true, so that fourth option is right. Fourth option is right. For every real number it is true. The equation 1 is true. Okay, the fourth option is correct. Then let us go to the next question, number 40. Question number 40. They define from R to R. Domain is real number. Codomain also real number. They define g of x is equal to, like here, g is a function from R to R. So this is g. G is equal to, they define 3 plus 4x. Input you can give real number. Output also we are going to get real number. Now what they ask here, g power n is equal to a plus bx. G power n. Then g power n value they given as G circle, G circle, G circle, G circle. How many times? N times. N times. Okay. Fine. Here, when I take here G circle G of x, can anyone tell that what is G circle G? G into G of x. See, G into G will write as G square of x here. G into G, G square, clearly. For example, G of x is equal to, you can take here 3 plus 4x. So, G square, okay. As for this, not like here only it is equal. Here only they given like that g power n of x is equal to G circle. So that we should take as equal. Okay, fine. I'll write very clearly the solution. This is somewhat important question. Okay, here. Question number 40. Question number 40. What is the question here? G from where to where? G from R to R. G of x is clearly 3 plus 4x. 3 plus 4x. Fine. Okay. What is the g power n they given? G circle, G circle, G circle, so on, G of x. And also g power n of x is equal to, we can consider as capital A plus bx. Okay, here for option verification only we have to do actually. So like that, what is A, what is B? See here for option 3 will be there. Here A is equal to 3, this, and B is equal to 4. When I compare directly, A is equal to 3, B is equal to 4. Which one of the following options are satisfying? A is equal to 3, B is equal to 4. This is first one is A, second one B. First one is A, second one is B. When I substitute n is equal to 1, okay, 2 square minus 1, 3 alone, 2 square 4. First option satisfying, second option satisfying, third option satisfying, fourth option also. Fourth option is not satisfying because 5 power 1 minus 1 is 4, but the first is 3. We can say directly when I substitute n is equal to 1, n is equal to 1, we are getting 4 comma 5 here, but here 3 comma 4 is there. A comma B value 3 comma 4. So n is equal to 1. Fourth option is clearly wrong. The answer might be first or second or third. Can we say directly? We can't say directly here. So now I am going to find that F circle, sorry, G circle, G circle, G value. Then after look at it. Okay. Let us take this is equation 1. Now I am going to find G square of x. Nothing but G how many times? 2 times. So here G circle G of x. Right side also you should take 2 alone. So let's see that. Don't think that here G square nothing but we should not take like G square means we should not take like 3 plus 4x the whole square. Here composite. We should not take whole square, right? So G of x we can write G of x is 3 plus 4x. This is clearly equal to, yeah, again if you see here, this is the x value. X value is 3 plus 4x, x value. Now in place of x, you can take 3 plus 4x. Then we are going to get 3 plus 4 into 3 plus 4x. Nothing but what? So this is equal to 3 plus 12 plus 16x. Nothing but here 15 plus 16x. Okay, then let us think again the option verification. When I take here n is equal to 2, when I substitute n is equal to 2 here, g square will get, okay, substitute 2 here, 2 power 2 plus 1, 3, 2 cube. What is 2 cube? 8. 8 minus 1 is 7. 2 power 2 plus 1, so 7 comma 8. But when we simplify here, if I compare this with like a plus bx, so a comma b value is 15 comma 16. Here a comma b value we got as, if I substitute that n is equal to 2 here, we are getting 7 comma 8. 7 comma 8 not equal to 15 comma 16. Then second option, substitute n is equal to 2, 16 minus 1 is 15. 15, 16, yeah, second condition satisfied. The third one, 3 square, 9. Okay, that's enough. No need for to do like G circle, G. Okay, and also this is also can be expressed as 15 can be expressed as, you can easily write 15 as, shall I write 16 minus 1 plus 16x. 16 minus 16 can be written 4 square minus 1 plus 4 square x. So this is g square. This is g square. The g power n value, the same way if you going on like 4 power n minus 1 comma 4 power n. Right? 4 power n is a, like bx. B is 4 power n, a is 4 power n minus 1. Like that also we can say. Just first you can give n is equal to 1. When I substitute n is equal to 1 here, so g of x we will get fourth option not satisfying, that when n is equal to 1, remaining first 3 options are satisfying. Now you have to find g square nothing but g circle g of x. G circle g of x we got as 15 plus 16 x. So when n is equal, same n is equal to 2, substitute in given option, second option alone satisfied. So second option is correct. Second option alone correct. Right? Now coming to next concept, inverse. Invertibility and inverse of a function. Invertibility means the function having inverse. The function inverse is exist. That we need to find inverse of a function. So invertibility means we have to check whether the given function is 1 and onto or not. When the function is 1 and onto, then only we can say that the function is bisective, their inverses exist. Many times I repeated, even inverse trigonometry also, first we check that given function is 1 and onto or not. Okay, so here also if they ask any invertibility, we need to check that invertibility, right? Okay, fine. Okay, students, here I think this is the important concept. I hope that you're having an idea about this inverse concept. F is a function from A to B. So then F inverse from B to A. Because F is 1 and onto alone, then here range is equal to codomain. This codomain becomes domain and domain becomes codomain. This is F inverse, right? Fine. See, this question number 41 is a logical question. I think so. F is injective function with domain, define x, y, z, and range is 1, 2, 3, such that exactly one of the following statement is correct, and the remaining are false. Remaining are false. F of x is equal to 1, comma, f of y not equal to 1, f of z not equal to 2, the value of f inverse 1. See here, f inverse 1. F inverse 1 is exist. Like to get the f inverse, f must be 1, 1 and on 2. F inverses must be 1, 1 and on 2. Okay, student, here f inverse is 1, 1 and on 2 here. Means f is 1, 1 and 2, f inverse also 1, 1 and on 2. Always. That is obviously. Like so, then how can you check it? Three cases they given here. Three different cases. F of x is equal to 1, and in that case we have to check whether it is 1, 1 or not. Then f of y not equal to 1, we have to check it. F of z not equal to 2, we have to check it. Okay, students? Right. Now, first case, I'm going to check all these cases here. I think so here. If you are not understood this question, once again I'm going to explain. So concentrate here. F of x clearly equal to 1 they given. Okay. Fine, students. Now, first condition. What is the first condition here? F of x is equal to 1. Then see here, f of y not equal to what they given here? F of y not equal to, just quite the opposite you can take. Quite opposite, like f of x1 equal to 1 means f of x is not equal to 1, you can take it the opposite contradiction way. Like f of y they given as not equal to 1 here, I'm taking equal to 1. And f of z, what they given? F of z value not equal to 2 is given, and I'm taking equal to 2. I will tell you why we want to take this. So f of x is equal to 1 in the sense f of y opposite. Remaining two cases you can take opposite. So f of x not equal to 1. In the same, otherwise you can see simply to understand this question. F of x1 is equal to 1 already given. That condition as usual and take. Remaining two conditions not equal they given. You should take opposite. F of y also 1, f of z also 2. Okay, see when you observe here f of x having 1, f of y also having 1. So different elements like input is x, y, the output is same 1 under f. Under f. Okay, so that clearly, otherwise I can write here. I told you domain is x, y, z. 1, 2, 3. F is a mapping from here like this. Okay, we don't know whether x is mapping to 1, x is mapping to 2, y is mapping to 2, z is mapping 3. We don't know. According to the first case, f of x is equal to 1 is given, and in the question they given f of y not equal to 1, f of z not equal to 2. I want to take as reverse. F of y not equal to 1 they given, I want to take equal. F of z not equal to 2 is given, I want to take as 2. Okay, now you can observe here x, in this case x and y. x and y having same image. F of x is equal to 1, f of y is equal to 1. So in this case, the function is not 1, 1. Second case, f of y not equal to 1 they given. Not equal to 1 they given. Yes or no? See here, yeah, f of y not equal to 1, f of z is not equal to. So in that case, student, what shall we take here? Yes. Shall I take here like this, the three condition, f of z not equal to 2 they given. So I want to take equal to 2. And f of x is equal to 1 is given, so not equal to 1. Remaining two condition. When I take f of x not equal to 1, remaining two condition I want to take equal. Already f of x is equal to 1, I want to take as not equal. And f of y value is what they given here? Not equal to 1 they given. Not equal to 1. Then already it is equal to 2. Then here in this case, f of y value is becomes 3. Because, okay. And see here, f of y value becomes 3. F of z is becomes 2. Here f of x also becomes 1. If it is equal to 1, then obviously it is 1, 1. But in the condition they given f of x is equal to 1, we are taking not equal to opposite side. Simply all three cases. So not equal to 1 means f of x either equal to 2 or equal to 3. If I take equal to 2, f of z is equal to 2, f of x is equal to 2, not 1, 1. If I take f of x value as 3, f of y is 3, f of x is 3. If you take f of x value 2, not 1, 1 because z and x are having same image. And if I take f of x as 3, then f of y is 3, f of x is 3, not 1, 1, both the cases. At last, if I take the last one is f of z is not equal to 2 condition, which implies f of z I want to take as, what is the f of z I want to take as? Not equal to 2. And first condition is that not equal to 2. In that case, we have to take, what about f of x? Yes, f of x is clearly, students, when f of z not equal to 2, then I want to take, and f of x is clearly not equal to 1. Same f of x clearly not equal to 1. And f of z value is not 2. So that f of y I am taking as 1. F of x I am taking as not equal to z, so that it must be equal to x. Okay, then final f of z value I am taking as 3. See, is this satisfying that condition? F of z not equal to 2 means f of z I am taking as 3. I am not taking f of x as 1 because f of x is not equal to 1. Contradiction. This is a logical question. I don't know how many of you understood. So f of x is equal to 1 they given. All of you observe here. The last step follow, like correct, then 1, 1. F of x here equal to 1 is given. If I take the third case, f of z not equal to 2 means not equal to f of z either 1 or 2. And clearly f of y not equal to 1 is given. And when I take third case, f of y I want to take opposite, like not equal to 1 is given, I want to take as equal 1. And f of x clearly equal to 1, f of x should be not equal to 1. And f of z already, third condition is not equal to 2. Okay, f of y is equal to 1 fixed. And f of z not equal to 2, nothing but f of z is what? Here f of x not equal to 1 means it must be either 2 or 3. 2 or 3. Okay, already f of z is not 2, it is 3. Then f of x is clearly 3 or 2. Now, f of y having different image and x having different image, z having different image. But if I take f is right side, f inverse of 1 is equal to y. So what is the option is correct? Y. F inverse of 1. Opposite you can take. When x is equal to 1, opposite is f of x not equal to 1. Here these are equal. Okay. If you are not understood, once again I am going to explain. Okay. So